All right, our next problem is all about how to use a calculator. This is actually something very similar to what you would see on a free response problem. Okay, let's take a look. A tachometer measures the speed in revolution per minute, that's RPM, at which an engine shaft rotates. For a certain bolt, the speed x in hundreds of RPM of the engine shaft and the speed s in miles per hour of the bolt are modeled by this function, s of x equals to 0.00547 x cubed minus 0.225 x squared plus 3.62 x minus 11. All right, a couple of things that we need to know. We need to know what the x represents. And if you look at this, the speed in hundreds of RPM of the engine. So the speed of the engine represents x. Well, x represents the speed of the engine. And the speed s in miles per hours of the boat are modeled. Okay, so s represents the speed of the boat. So this is saying the speed of the boat depends on the speed of the engine shaft. All right, so let's take a look at what they want us to do with all this information. Part A says, describe the end behavior. End behavior, you're looking at purely just the equation. Is it a positive or negative equation? Is it an odd or does it have an odd or even degree? In this case, it is a positive odd. And we know that a positive odd goes up on the right, goes down on the left. So when they're writing end behavior, they're asking for this. As x approaches negative infinity, so on the left-hand side, what is happening to my graph? S of x, because that's my graph, approaches, since on the left-hand side it's going down, it goes to negative infinity. That's only one side of the end behavior. Now I have to give me the other side. As x approaches, now I'm talking about the right-hand side, so that's positive infinity. What's happening to my graph? S of x approaches, the graph is going up, so the S of x approaches positive infinity. That would be my end behavior. I haven't gotten anything with the calculator yet, so let's keep going. It says interpret the point, so they actually gave you that point. Now, whenever they see the word interpret, what that means is they want you to tell me what x represents and what y represents using the number that they give you. So in this case, this is my x and this is my y. This is where I actually have to go back into the problem and figure out what those two represents. X represents the speed of the engine in RPM. So I can say what's the speed of the engine? At 10. What's the unit of the speed of the engine? At 10 hundredths of RPM. What's happening at 10 hundredths of RPM? 10 hundredths is 1,000 RPM, by the way. Now you're looking at the y. What is my y? S is the speed of the boat. So you have to tell me the speed of the boat is, well, what is the speed of the boat? What does it say? It says 8.170, and speed of the boat is in miles per hour. Miles per hour. And that's all you have to tell me. So at 1,000 RPM, the speed of the boat is 8.17 miles per hour. You have just interpreted a point. Tell me what the x represents and tell me what the y represents and use it in a sentence. All right, now it's about to get interesting. It says determine the zeros. And since this is a calculator problem, I go immediately to my calculator. And since I'm looking for zeros, I know I need to graph that equation. So I'm going to graph the equation. Let's see if I can. Yeah, there we go. I'm going to go to my new document. Don't save it. Pass, add a graph. Let's type it in. We have 0.00547 x to the third power minus 0.225 x to the second power plus 3.62 x minus 11. Okay, let's take a look. Ooh, this is interesting. I see a graph that goes on this side. It doesn't look like I have the whole graph, so I'm going to want to zoom it out a little bit. And the zoom, I'm going to zoom it out a little bit just to see what the graph looks like. Now remember, if you're looking at your end behavior, one end of the graph has to go up, the right end has to go up, the left end has to go down. So when you're zooming out, keeping that in mind. So menu, I'm going to zoom out. Oh, this is looking much better. Okay, so now I can see where my zeros are. My zeros is where the graph hits the x-axis. I can go to Menu, Analyze Graph, go to 0, and highlight that. It says the 0 is at 3.890, comma 0. So when they're asking for the zeros, you're asking for my x. X equals to 3.890. Now, what does that mean, right? Another interpret the meaning of the 0 in the given context. Well, remember what we said? We said that the x is the speed of the engine. So we can say when the engine speed is, well, it's in hundreds of RPM, so 3.89 hundredths of RPM, or you can say 389 RPMs. 3.89 hundredths of RPM. What's happening when the speed of the engine is at 3.89 hundredths of RPM? This is at a 0. Y is 0. So that means the speed of the boat, it's 0 miles per hour. Well, what does that mean? That means the boat is not moving. Or you can just tell me that the speed of the boat is at 0 miles per hour. That would work too. Okay, keep going. What's the speed of the boat? Okay, so they're looking for the speed of the boat when the tachometer reads 500 RPM. Remember, 100 RPM, if you don't remember, if you go back up, hundreds of RPM is talking about x. That means that this is saying x equals a 5. They're asking you, what is the speed of the boat? So they're asking you, what does y equals to, or what does s of x equals to? This is a very classic case of tracing your graph or going to your table. Here's my graph. I know that x is equals to 5, so I can easily go to Menu, Trace, Graph Trace, and just type in 5. When I type in 5, one of the things will pop up that says x equals to 5. Hit Enter, and if you look on the bottom, that's where it's going to tell you. When x equals to 5, when your engine is going at 500 RPM, your speed of the boat is 2.159. So when you're writing it down, 2.159 is good, but you need to make sure you're writing the units, miles per hour. That's not very fast for a boat, is it? All right. So next one. What is the tachometer reading when the boat travels 15 miles per hour? Well, that's my y. Y equals to 15 miles per hour. That means I'm asking, hey, what's the x value? This, you are going to want to do this. You want to say 15, y equals to 15. So that means that when I'm looking at this equation, this function is the 15 goes in s of x. So really, this is what they're asking you. 15 equals 0.00547 x cubed minus 0.225 x squared plus 3.62 x minus 11. They want you to solve this equation. Remember that trick that we talked about when we do solving equation using a calculator. You already have this equation in graph f1 of x. What you're going to do, you're going to take the other side of the equal sign. Remember how I used to split up the equation using the equal sign? Take the other side of this equal sign and type that, whatever that's on the side, into f2 of x. So in this case, I'm just going to write y, or f2 of x, equals to 15. Here's my graph. I'm going to go to tab, and then type in f2 of x equals to 15. Just type in 15, hit enter. There's your graph right there. This is when the speed is at 15 miles per hour. This is the speed of the boat at different engine rotation or different engine speed. So when is this graph equals to this graph? You're looking at the intersection right there. So you're going to go to Menu, Analyze Graph, Intersection, and just highlight that intersection. That intersection tells me 19.863. Let me write that down. This is what I get. 19.863, comma 15. Well, that's my intersection, but that doesn't answer the question. The question says, what's the tachometer reading? What's my x value? My x value is 19.863. Don't forget to give me the unit. And in this case, it's in hundreds of RPMs. And that is your final answer. Now, here's the next thing. What is a realistic domain and range? If you look at your graph, domain, remember that domain is your x, range is your s of x, or is your y. Remember that for domain, you're talking about engine speed. Remember for the range, for the y, you're talking about the boat speed. So what's a realistic number for engine speed? Well, can your engine have negative speed? That wouldn't make sense, right? What happens when your engine is at when your engine speed is at 0? Well, if you look at that, the graph right here, when engine speed is at 0, your boat speed is actually at negative. Can you get a negative boat speed? Probably not, right? So the most realistic starting point would be when the boat is not moving, right there at your 0. And we already found that 0. That is at 3.89. So realistically, for your domain, it starts at 3.890 hundredths of RPM. And it could keep going on forever. Your boat could go as fast as it wants. And then for the range, if the domain starts at 3.890, then the range would be at 0, because your range, the slowest that a boat can go would be at 0 miles per hour, and then it can go into the infinity. The boat, depending on how high the horsepower is, the boat could go as fast as it wants. How realistic is that? Probably not too much, but it's realistic at what I know about the speed of a boat. I can always go research the top boat speed, and then get a endpoint for my engine speed and for my boat speed. Either way works. And we have just completed the entire free response problem. Your turn.